Hello everybody, it is me, Steve. It is, as I make this video, January 8th, 2018. I am going to put this up before I put up my part 3 of the lunar transit preparation, but I just wanted to do this. I took some video on January 3rd, 2018. I took the volume out of here because I wanted to show you, or I wanted to talk over the video. But here you can see the date and time, and when I'm done with you're also going to see words across the screen, my direction, heading, that kind of stuff, zoom, the amount of zoom I'm using. But I'm doing this because I'm going to compare it with Wolfie 6020's video of the moon that he caught in Australia, Sydney, Australia, the night before. If I would have known he was doing that, I would have done it the same night. But because I wanted to compare, because in the Northern Hemisphere, the moon looks rotated as opposed to the Southern Hemisphere, and I'm going to explain why that is, and I'm going to use our latitudes to explain that. But basically here, first, it's just me trying to set my camcorder, and don't worry, it is going to clear up. My camcorder does get the moon pretty well, even though it's like 12 years old. I just wish it could. I just wish I could afford a new one to do this more often. So just watch it, and you'll see I take a couple stills when I compare it to Wolfie's video at the end. So just sit back and watch, and I will pick up when the video here that you're watching of my live footage ends. Okay, so what you see here in the upper left is a still shot from the video you just watched of the moon from my vantage point on January 3rd, 2018. The lower right photo is from Wolfie 6020's video the night before on the 2nd when there was a full moon, the supermoon. But I'm going to give him full credit, but before I do that, you see here in this photo, the moons are oriented up from our vantage point here. Wolfie's plainly says that. Mine does not. I do not have the equipment he does. I have a crappy tripod with a leveling bubble and an old camcorder, so even with my leveled, I have to measure the offset or tilt of my camera when I do stuff like this. And in this case, it was roughly, I believe it was 10 degrees, so I had to reorient the photo of my moon to compensate for that. And then what I did is I just took these two photos, drew yellow circles around them with crosses in the middle so you can find the dead center, and then I put a black dot on each moon with an identifiable feature present in both of the photos. I forget what this feature on the moon is called. I apologize. It's in the southern hemisphere of the moon, not that far from the lunar South Pole, but I apologize for that. Anyway, let's move on. Here is Wolfie's info. This is the video I took it from. The red box here sits there and says he was using an alt-azimuth mount, so his footage is correctly oriented with up, which means the top of his photo is directly up from ground level as he was looking at it. I will link to his video below. Alright, so we go back here. My latitude is about 41.5 degrees north. Wolfie's is about 33.9 south. Alright, because I am in Indiana, he is in Sydney, Australia. So I draw my angles here, as you can see, through my black dot on each of those photos that I previously showed you. So I add 41.5 degrees to 33.9 degrees, and I get 75.4 degrees. I don't need to subtract the 33.9 from the 41.5. I add it because some people see the minus instead of the south latitude and they assume it's a subtraction, but it is not. I am 75.4 degrees latitude difference between him and me. We only use the negative for the south because it's south of the equator, just to differentiate the two hemispheres. So I measure these two angles now, and I get 32 degrees for my upper left one, which is my photo, and I get 53 degrees for his photo. I add those two together, I get 85.0 degrees. 85.0 degrees is not equal to 75.4 degrees. Why is the discrepancy? Even though you can clearly see that our two photos are rotated relative to one another, because he's in the southern hemisphere, I'm in the north, there's still a discrepancy. Why is that? Well, because we recorded on different days. So I went to the Moon Phase 2017 Northern Hemisphere, NASA's continuous. They go through the whole year showing the moon and how it moves relative to your vantage point in the northern, in this case, the Northern Hemisphere, which is kind of cool. But they do have the moon oriented north-south in their images. But if you're standing on a curved surface such as the Earth, you're not going to see the, it's going to be tilted relative to you. It's not going to be a direct thing. So why am I showing you this? Well, those two photos you just saw on the right side, here's the top one. All right. This, I took a snapshot of the screen, and I wrote down in yellow what I have in the yellow box just in case you couldn't see it. All right. And then I went to the next day, because these two phases were about the same difference as Wolfie's and mine. He is in his universal time, he's 17 hours ahead of me. All right. So this is what it looks like in the Northern Hemisphere during November 6th, 2017. I tried to take a screenshot as close as I could to our time separation, but obviously my fingers aren't that fast, and these videos move pretty quickly. But why am I doing this? Well, because this is important, because if you look between the previous photo and this one, not only did the phase of the moon shift, but the actual relative tilt from your vantage point also moved. That's because the moon is, orbiting the Earth, but we don't always see the exact same. It doesn't always look the exact same to us. Not only is it different from hemisphere to hemisphere, it's also different from night to night. And if you watch NASA's videos, you'll see it kind of weighing back and forth, because the moon is not on our plane of orbit. It is tilted 5.1 degrees. All right, so I take these two drawings and I measure angles on them. The same thing I did before. So I get 64.5 degrees and 73. My little degree symbol is not on my 64.5. I apologize for that. And I get 73.0 from the next night. All right. And as you can see, that the phase is a waning gibbous, and I was observing a waning gibbous the night after Wolfie caught the full supermoon. So now what I do here, I take the difference of these two angles. I have 73.0 degrees minus 64.5 degrees. I get 8.5 degrees. So I add that 8.5 to the observed 75.4 because it has rotated to my vantage point looking up in the sky. And now I get 83.9 degrees. So I've compensated for that extra night of not only the moon phase changing, but its apparent rotation looking for my vantage point. I hope that's clear. Okay, so this just real quick is my moon on top, Wolfie's on the bottom. So 85.0 minus 83.9 is equal to 1.1 degrees. So when I reset this, my margin of error was only 1.3% when I took the two different day spans into account. So it works. I had a really small margin of error, and I'm actually pretty shocked about that. Doesn't usually happen with me. Let's see, this next line this here is just to show you. I'm actually going to do a separate video showing you how the moon looks tilted relative to someone in the Northern Hemisphere and someone in the Southern Hemisphere, and the degree of separation and all this stuff. But I was going to include it here, but I decided not to because the video is going to be long enough. But what we have here is I took the January 4th moon, 2018, which, you know, for universal time, which was about the same time as I was observing it in my January 3rd video. Universal time is not the exact same thing as with time zones. It trumps time zones. So that's why it's called universal time. But anyway, so just to know how much the moon was tilted from my vantage point, according to NASA's video, this is just something I just wanted to show you. As you can see, our two moons look pretty similar. We have similar phases, so it's the right day. But you take the reference line from NASA's photo and then, or screenshot that I took, and then put it on my moon, and we have an 83-degree tilt. And like I said, that's due to my vantage point on that day observing the moon in that phase. So, anyway, that is it. I hope you learned something, and if you have any questions, feel free to leave them below.